we're going to say, well, if we know 3 points and that a quadratic goes through those 3 points, can we actually work out the equation of the function? And the answer is yes, absolutely. I want to work you through an example of how we do that today. So the question that we're looking at here gives us 3 points. It's the example in your textbook, example 31. And we're going to say we want to find the quadratic that goes through -1, -3, and 0, 3, and 2, 21. So if we know that a quadratic function, when we draw it, it goes through those 3 points, or if we discuss another way, these 3 points satisfy the equation, can we work out what the equation is? To do that, we need to work in a kind of a simultaneous equation way. That's not almost. Actually, we're going to apply our knowledge of how we use simultaneous equations to do that. What we have done in simultaneous equations in the past, though, is just look at things with two variables. And to do these, we're going to look at things, simultaneous equations with 3 variables. So we actually need to, I guess, expand the way we do it. We're going to be working with far more equations. We generally work with 2 equations, and number 1 and number 2, and we work together with those. Now we're going to actually expand to a lot more equations. So here we go. So I'm going to start by saying, well, the function that we need to find is in the format ax squared plus bx plus c. Okay, so that's our general form of a quadratic equation, ax squared plus bx plus c. And I know that if I put in any of those points will satisfy the equation. When we know what a, b and c are, those points will satisfy the equation. But what are those a, b and c? We need to figure those out. So I start just by putting in each one of those into our function of general form. So the first one, I'm going to put the function of -1. So it's a brackets -1 squared plus b brackets -1 plus c. But I also know what the function equals at that point, because that's the y coordinate of this point. Okay? And so I know that equals -3. Okay, so that function at that point equals -3. But I can also do some simplifying through here. So -1 squared is just +1, so that becomes just a, and that becomes -b plus c. So I've got myself there one equation I'm going to use to solve simultaneously. I'm going to label that one number 1. Okay, now I'm going to use, so that was using this one here. Now I'm going to use 0, 3. So at the function at 0, I might just I'll just draw a line through here just to say, right, there's a new section of working here. Function of 0 is a times 0 squared plus b times 0 plus c. Now what is the function at 0? The function at 0 equals 3 from this point over here, so 3 equals, let's simplify this, 0 squared, 0, that term disappears, 0, all we've got left is just a c. Okay, I'm going to call that one number 2. Now just to say, you won't always have a nice, neat equation that comes out with one of the variables already worked out there. It's because one of the points here that we were given has an x-coordinate of 0. And that x-coordinate of 0 gets rid of this ax squared term and the bx term. So we won't always have a nice and neat one like this. In this case we do, it makes it easier for us. Okay, less working for us to do. But let's call that one number 2. Let's put the third one in now. So function at 2 equals a by 2 squared. Sorry, the square should go up here. Plus b times 2 plus c. And that function at 2 equals 21 equals 4a plus 2b plus c. And that is equation number 3. Okay, so now I've got my 3 equations, and I need at least 3 if I've got 3 variables. Before, when we were working with 2 variables in our simultaneous equations, we only needed 2 equations. Now I need 3 because I've got my 3 variables. Okay? Even more so, again, I'll say again, this one here, because of one of the points is at x equals 0, this becomes a very nice equation. If I had another one with A, B and C all written in there, it would actually become very obvious why we need all 3 and we need to work with all of them. Okay? So let's just continue working with this one. So I've now got, let's say, I'm going to sub equation number 2 into both 1 and 3. Okay, so I'm going to sub that equation into both of them because I can now put those in and get rid of the c in both of those. So it becomes equation number 1, negative 3 equals a minus b plus, let's say, what's 3? Simplify it a little bit. Take away 3 from both sides, so negative 6 equals a minus b. I'm going to now call that equation number 4. So I've now created a new equation from combining number 1 and number 2. And then I'll also go negative 3, sorry, not negative 3. I'm going to sub this one into number 3. So it's 21 equals 4a plus 2b plus 3. Again, just some simplifying. 18 equals 4a plus 2b. And that's now equation number 5. So we're now working with 5 up to number 5 equation. Yes?
Sorry, when you started the next kind of section,
yep.
What did you sub into?
So I'm subbing number 2, this one here, subbing 2 into 1 and 3. So I've done them both.
Oh, okay.
So this is number 1 here, and this is number 3 here. So I've just put that into both of them,
yep.
And then simplified where I can to create 2 new equations, 1 from each.
Can't you simplify the equation 4 to just a equals 0?
That's a 6 and that's a b. Sorry, my writing.
Oh,
that.
6.
That's a b.
Okay, yeah.
6 and a b. Yeah.
Oh.
Yep. Okay. But now we've got back to a point where we can actually do what we have done in the past with our simultaneous equations. We've got 2 variables represented now. It's a and b. That's all we've got left, and we've got 2 equations, and so we can do that. We've got either elimination or substitution. Which one do you want to go with?
Elimination.
Elimination. All right. So what do you have to do for elimination? I'll help you out with that. And so we're going to say, all right, I want to get the same number coefficient in front of one of the variables. And so I'm going to change the a's to the same coefficient, and it could be positive or negative because you can eliminate either way. And all the b's might be easier because there's a 2 there. Let's do that one. So I'm going to go equation number 4 multiplied by 2. So I'm going to multiply that whole equation by 2, so I can get a 2 in front of that b. So it becomes negative 12 equals 2a minus 2b. That's a new equation I'm going to use, so I'm going to label that one again. Every time I create an equation I'm going to use, I'm going to label it. So it's number 6. And I'm going to say number 5 equation, this one here, plus number 6. Why am I doing that? Because when I add those 2, I've got a positive 2b and I've got a negative 2b. When I add those 2 equations together, I get rid of all my b's. Okay, and that's what I want. Because I want to be able to get just back to 1 variable left. So in this case, because 1 was positive, 1 was negative, I add them. If they were both positive, I'd subtract the equations. Okay, that's the elimination method. Either add or subtract based on whether they're the same sign or different signs. In this case, they're different signs, so I add them together, but that gets rid of them. So I need to go through and add the left-hand side. 18 plus negative 12 gives me 6. 4a plus 2a gives me 6a. And as I said, 2b plus negative 2b gives me no b's. Okay, and so that's all I've got left. 6 equals 6a, and a equals 1. Alright, so I've worked out what my C is, I've worked out what my A is, I need to work out the B now. Okay, so I look back to an equation, I go, where can I plug in A equals 1 into something that looks easy? This one here looks nice and easy up here. Let's do that one. In fact, no, this one is even easier because I've got a positive B. Let's use number 5. So I'm just going to pop under here to run out of room. I'm going to sub a equals 1 into, which equation that is, number 5, and so that becomes 18 equals 4 times 1 plus 2b. 18 equals 4 plus 2b, 14 equals 2b, b equals 7. I've worked out my C first, and then my A, and now my B. So I'll go up with my 3 variables I need to do. So to finish off the question, the last step, I'll write that just here. Therefore, the function equals, and I'll just write them out now with the numbers in front. So A equals 1, so that's just x squared. I don't need to write the 1. B was 7 here, plus 7x, and C was 3, plus 3. That is the equation of the quadratic function that goes through those 3 points.